Process capability. A process can be defined as a sequence of procedures, operations, or steps that converts inputs to outputs. Every process has certain amount of variation which can be measured, monitored, reduced, and or controlled. By taking accurate measurements using reliable, well-maintained equipment, variation in the process can have little impact on the quality of the output, hence able to produce acceptable products on a consistent basis. Process capability defined. Process capability is defined as a statistical measure of the process variability of a given characteristic, which can be used to assess the ability of a process to meet specifications. To determine how a process is operating, we can calculate process capability (CP), process capability index (CPK), preliminary process capability (PP), and preliminary process capability index (PPK). The CP and CPK indices are used in evaluating existing and already established process in statistical control, while the PP and PPK indices are used in evaluating a new process or one that is not in statistical control. CP determines if a process is capable of making parts within specifications, and CPK determines if the process is centralized between the specification limits. Here, for instance, you have the specification, then you have the process is out of specification. You say such a process has too much variation. But when it is in between specification, is within specification, the green line shows the process is within specification. That is a good process. And when the green line further reduces, then such a process is said to be also within specification towards the center line. So these are three different scenarios of a process being within specification, being out of specification, having too much variation. The CP index is a fundamental indication of process capability, which is calculated using the specification limits and the standard deviation of the process. Most organizations require that the process CP equals 1.3 or greater. The CPK index, on the other hand, examines how close a process is performing to the specification limit, putting into consideration the common process variation. The larger the value of the CPK, the closer the mean of the data is to the target value. CPK can be calculated using the specification limit, standard deviation or sigma, and the mean value. The value should be between 1 and 3. If the value is less than 1, the process is in need of improvement. Accurate process capability study depends upon 4 basic assumptions regarding the data. First, no special causes of variation in the process. Process is in a state of statistical control. The data used for study fits a normal distribution, exhibiting a bell-shaped curve and can be calculated to plus or minus 3 sigma. The sample data is true representative of the population randomly collected from a large production run. Why measure process capability? Monitoring process capability allows the manufacturing process performance to be evaluated and adjusted as needed in order to assure that products meet design or customer specifications or requirements. When used effectively, the information derived from the study can help reduce waste, improve product quality and consistency, lower cost of manufacturing, and the cost of poor quality. To determine how a process is operating, we can calculate the process capability index, the process capability. Calculating CPK. CPK are classified into two, the upper and the lower, denoted as CP subscript PU and C subscript PL. Again, denoted as C subscript PU and C subscript PL, respectively. C subscript PL equals process mean minus lower specification limit in brackets divided by 3 times standard deviation in brackets. While C subscript PU equals upper specification limit minus process mean divided by 3 times standard deviation. Now we are dividing by 3 because specification limit has an upper bound and a lower bound, and since 6 sigmas, that is 6 standard deviations, account for nearly all eventualities on a process, assuming normal distribution. Hence, dividing by 3 enables us to look at only one side of the distribution. Here is a typical example. CPK is simply the smallest value of the CPL or CPU. CPK is equal to the minimum of the CPL and the CPU. Out of the CPL and the CPU, the upper specification limit and the lower specification limit, process capability of each, the smallest value of the two represents the CPK. So CP again is equal to upper specification limit minus lower specification limit all over 6 sigma, 6 standard deviation. While CPK is equal to the minimum of the process mean of the CPL and then the CPU.